In this video, we're going to look at mutually exclusive and exhaustive events, as well as how to predict how many you should get of every item. So let's have a look at the first one. So, mutually exclusive is also known as mutually exhaustive. In other words, things cannot happen at the same time, and all the probabilities are taken care of. Now, the probability of something that definitely happens is, as far as you are aware, 100% or 1. So what we've got to do is work out what do we have to add to 3/8 to get 1. The other way of doing it is we're going to do 1 take away 3/8. Now we're going to turn this into a fraction, make the denominators the same, so we go 8 over 8 minus 3 over 8, and the answer is 5 over 8. You might not need to go through that whole process to work out the answer, but what we're trying to work out is what's going to add to 3/8 to make a whole. The next one, if the probability of Timmy winning a tennis match is 0.7, what's the probability he doesn't win? So we know they're mutually exhaustive, you either win or you don't. So we do 1 minus 0.7, which happens to be 0.3. So that is our answer, 0.3. Now these questions are often given to us, especially in GCSE, in table form. So here is our table. There are red counters, blue counters, yellow counters, and green counters in the bag. One counter is picked from the bag at random. All of these are the options we've got in the bag. So we've either got red, blue, yellow, or green. And we know all together the probabilities must add up to 1. So what have we got? We know red is 0.2. We know blue is 0.4. We know yellow is 0.3. If we add all of those together, we get 0.9. Now remember, it has to add to 1. So what is 1 take away 0.9? Hopefully you know that it's just 0.1. If you're struggling with your decimals, remember you can write 1 as 1.0, write 0.9 underneath, and then we can use the carry method. So we borrow from the 1, becomes 0, that now becomes 10. 10 take away 9 is 1, carry the dot down, 0 take 0 is 0. So my answer is 0.1. So that's what happens if the events cannot happen at the same time and we've got all the probabilities. So they're called mutually exclusive or exhaustive. Don't worry so much about the wording. Just realize that if you want the probability of something being opposite, you do 1 minus. Now the other piece of work you're going to have to do today is about expected frequencies. So what would you expect? So we can estimate the number of times an event will happen by working out its expected frequency, how many times it should happen. Now there's a little formula here. It's a lot easier than it looks. It says to find the expected frequency of an event, something happening, is the probability of the event times the number of trials. And here it tells you that trial just means an action that could lead to the event happening. For example, a toss of a coin or a roll of a dice. So let's have a look at a roll of a dice. So we're going to roll the dice 300 times. This is the number of trials. It's how many times we're actually rolling our dice. Now, how many times would we expect to get a 5? Well, the probability of getting a 5, hopefully you all know, is a sixth. So the probability of rolling a 5 on a die is 1 over 6. So we're going to take that probability of the event and times it by the number of trials. So it's going to be 1/6 times 300. Now remember, we can make that over 1 times the top times the bottom, and 300 divided by 6 is 50. Let's try a different one. How many times would you expect to get a multiple of 3? So we want to get a multiple of 3. Well, let's think. So on a die, we've got the numbers. I've lost my little drawing tool. Hang on. We've got the numbers 1, 2, 3, 4, 5, and 6. How many of these are multiples of 3? Well, hopefully you remember your multiples of 3 are your 3 times table. So that is 2 of them. So the probability of a multiple of 3 is 2 out of 6. So once again, we're going to do the probability of the event times the number of trials. So that's 2 over 6 times by 300. Times the top, times the bottom, divide, gives us that 100 times we should expect to get a multiple of 3. 50 times we should expect to get a 5. Right, how about even number? How many even numbers on there on the dice? Hopefully you know that there are 3 even numbers. So the probability of getting an even number is 3 out of 6, or you probably already spotted that it's actually a half. So once again, probability of the event times the number of trials. So it's a half times 300, because this is still about our die that we rolled 300 times. And a half of 300 is 150. And that's how to deal with the estimated number of frequencies as well as exhaustive events.